So we are here in this episode. We are here to talk about choosing the right model for your data, and we've learned that once you have gotten your data ready, the next step is to choose an appropriate machine learning algorithm or model to find patterns in your data. So what are some of the things we should note? So SKlearn refers to machine learning models as algorithms or as estimators. So take for example classification problem. What is a classification problem? So with a classification problem, we know that it's predicting a category. It's classified, either it's classified into two categories or three categories. So take for example something like disease, a disease or not. And then so sometimes you'll see CLF, which means that is a short form of classifier used as a classification estimator, instant variable name. And then the second one, we talked about the classification problem. So the second one is gonna be a regression problem. So as we know, the regression problem is you're predicting about something. It can either be a linear regression model or multiple linear regression model. So in a regression model, we are predicting a number. We are predicting actually a number. For example, the price of a commodity or the price of any housing. And then we have unsupervised problems. So that includes clustering, right? Which is grouping unlabeled samples with either similar unlabeled samples. So if you know what kind of problem you're working with, one of the next places you should look is at the scikit-learn algorithm. We have the cheat sheet here. So let me just show you the cheat sheet, which is here. So this is the cheat sheet we are going to use, and we are going to start with here. Either someone we have 50 samples and above, we proceed. If not, we need to get more data. And then when we are predicting a category, is it either is this a category, yes or no? And that's how we go. So I'm gonna demonstrate this using an example and I'm going to use a California dataset, and so that you can understand on how this goes. So looking out at this cheat sheet and follow it some of the problems we are working on. So let's start with a regression problem. That's we are trying to predict a number. So as I told you, we are going to use a California housing dataset, which is inbuilt in scikit-learn database model. So let's start with that being said, let's start with that. Okay, yeah. So what do we do here? So from SKlearn data sets, import fetch housing. Then we're gonna store this one into something called housing. So you're gonna say fetch California. It's supposed to be California this way, yeah. So California. I'm gonna correct this too here. The spelling of California is gonna be that way. So fetch California housing that way, and then so housing here, housing, hit shift and enter. So let's wait for this. Perfect. You can see it has imported our dataset, and we have the data here, and then we have the target here. So let's see. Let's turn this first into a data frame. So to turn this one into a data frame, we'll be using housing. is equals to pd dot data frame housing. Then the first one is gonna be data, then our columns is gonna take the target columns. The dataset can be found online. You can just search it for the dataset, California housing dataset. Can be found in the SKlearn. So feature. So then let's display the data set here, df. So let me hit shift and enter. Let's see, pd is not been defined, so I need to import pandas spd. So shift and enter. Perfect. You can see here, this is our data set. Now you can see that it has 20,640 rows and 8 columns, namely these housing, age, average rooms, average bedrooms, population, and so. So what is our target? We need to add our target to the data set here. So we get our target here, which is this. I'm going just to show you. So the first thing we need is to add our data set, is to add our target to the data set here. So housing df target. So we're gonna add our target here, which is equals to housing. Sorry for that, it's just my phone. So housing target here, then H shift and enter. Perfect. Let me display this again. Let me run this so you can see that. Perfect. We can see here we have added our target. So what is the next step after this? So the next step after this is we want to know now where they want to go into prediction, right? And we want to know about the right model we are going to use, right? So I'm going to walk you through this cheat sheet here. So here we go. So with that being said, so we are trying to predict in this data set, we are trying to predict the regression problem, predict the California housing data set. Okay, so the goal of a California housing dataset is to predict a given district's median house value in hundreds of thousands based on things like age. Here we have age, and then we have the number of rooms, and then we have the number of bedrooms, the number of people living the home, and more others like longitude, latitude, and others. So with that being said, so we want to know what kind of problem we are dealing with. So we are trying to predict the district's median value, of which that one is it's a number. So here we go. So let's see this. So let's start with here. Do we have more than 50 samples? Yes, we have 20,640 rows. So we have more than 50 samples. Good. Are we predicting a category or no? So we are predicting a number. So definitely it's not a category. So no. Here we go. Are we predicting a quantity? Yes, we're predicting a quantity, since we are predicting the district's median house value, which will be in hundreds of thousands of dollars. So that's correct, right? So we proceed here. Is our samples more than 100,000? Yes, our samples is more than 100,000. So with that being said, here we go to the next feature, that is yes. So with yes, we go to do we have a few features should be important? Are there few features that are important, or like are there features that are important? Since we are working with this data set here and we do not know like really which features are important and which features are not important, we should go with this one here. No, since there are some aspects that are important, but that doesn't mean you should not try these other ones here. You should actually, when you get time, just run all of them and see which one works best for you. But for now, let's say we're going to go with the range here. So with that being said, let's go with the range here, and then so let's go with this. So let me just show you what's gonna happen here. Import algorithm. So from SKlearn linear, because it's a linear model, import rich. So, and then we have to split our dataset into two categories, but the X and Y. So we split our dataset. Split. So we have X, which is equals to housing df dot drop. We want to drop the last column here. So drop here is gonna be the target. So target axis is equals to 1. So y is equals to housing df. Now we're gonna take the target right now. This will be our target, and then so that was creating our dataset. So we have to split into training and testing. So split into training and testing. Perfect. So we have to split into training and testing. So that being said, it's gonna be x train, y train, then before that let me just include the x test. So it's gonna be y test is equals to train test split xy. Our test size is gonna be 0.2. So perfect. Let's go ahead. Then we have to fit our model. Ciao.